All right, class, this is Mr. Stumbaugh. We're going to run through 1-6 and 1-7 today. A couple things you need to know. Well, actually, hold on. Let me go back. A couple things we need to go over. A couple definitions. We have a graph here. The x-axis is this horizontal line at 0, y equals 0. The y-axis is this vertical line that is x equals 0. Okay? And anytime you hear something about the origin, it's this point right here in the middle where they cross at 0, 0. Now, when you see anything about an ordered pair, like the origin right here is an ordered pair. You'll see parentheses, a number, comma, number, parentheses. That is an ordered pair. Your x-coordinate is always this first number, and the y-coordinate is always the second number. So it'll look something like this, x, comma, y. It'll always be in alphabetical order, if that helps. But this is what your ordered pair looks like. Okay, so now we can talk a little bit about these ordered pairs right here. You have your set notation, and it'll give you, a certain number of ordered pairs to work with. A couple different ways we can express this. We have mapping. Well, actually, let's start here with the table. I'm going to scroll down. You have a table. What you do is you take all your x-coordinates and you put them here in number order. So we have 1, then 4, then 5. And then in a table, you match up the y-coordinate with it. 1 has a 3, 4 has a 2, and 5 also has a 3. Okay? So that's what a table will look like. A map over here, you still have your x-coordinates in number order. And then over here, you put your y-coordinates also in number order. And if you have any repeats on either side, you just write the number one time. In this case, we have 2 3s, but I'm only going to write it one time. So, what we do now is from our x-coordinate, we draw an arrow to its y-coordinate. So from 1, we go to 3. From 4, we go to 2. And 5 also points towards the 3, because they both have the 3 as their y-coordinate. Then, of course, we can also graph them. We have 1, 3 here, 2, 4 here, and 5, 3 over here. And we graph them like that to see them on a point. Domain is the first number in each pair, so it's your x-coordinate, and your range is the second number in each pair, so your y-coordinate. So in this case, our domain will be 1, 4, and 5, and our range will be 2 and 3. Another quick example, we have 4 ordered pairs here. We have our domain. Alright, so we got our 4 ordered pairs here. Our domain, we just take the first number from each one of these, 4, 3, -4, and 0. When you write domain and range, it doesn't necessarily have to be in number order. In our range, we got -3, we have 2, we have 1, and -3. So this one we put in number order, this one we didn't. It doesn't really matter whether you put them in number order or not. A lot of times in the book you will see it in number order, and that's just when you're graphing. That's really your kind of maximum and minimum. So now we go to our table and write these. These also don't have to be in number order. I like to put them in number order, but it's totally up to you. You could do them 4, -3, 3, 2, -4 and 1, and 0, -3, just as you see it here. Or you could start with -4, then 0, then 3, then +4, and do it that way. Now when you're mapping, these do have to be in number order. -4, 0, 3, and 4. And your range, -3, 1, and 2. And remember, we have -3 twice. Draw our arrows. So your mapping has to be in number order. Your domain, range, and table do not. And now we just go over here and graph what we have. We have -4, 1. We have 0, -3. We have 3, 2. and 4, -3. Talking a little bit about independent and dependent variables. Both of these can change, but one depends on the other, which is why they do dependent and independent variable. When we do our graphs and stuff like that, y depends on x, so that's why we always have y equals, mx plus b. Whatever we plug in for x, we can plug in whatever we want, and y depends on what this number is, because all this changes. You might see some story problems, like the amount of money you make depends on the number of hours you work, or the air pressure of a tire depends on the temperature of the outside air. The water level of a river depends on the amount of rain. All of these, the amount of money you make, pressure of a tire, those can change, but what it's saying is it's depending on whatever we have here, so number of hours worked, or the pressures depending on the temperature of the air. Now this part's pretty simple. We just need to find out if it's a function or not. Each input only has one output, okay? That will always be a function. Now, you can look at your ordered pairs and see if you have a function or not. If your x repeats anywhere, then it's not going to be a function. Your y is able to repeat, like here, we have 2, 2, and 2. It is a function. It is able to repeat. So your y's can repeat, but your x's cannot. When you have your map, as long as you have the number of arrows as you do the number of inputs in your domain, you will have a function. So like if I go back here, I have 4 numbers in my domain, or my x, and I have 1, 2, 3, 4 arrows. 4 arrows, 4 domain numbers. This will be a function. On something else that may have this repeated to where it's only 3 but 4 arrows or whatever, then that means you have a repeated number in your domain, and you can't have that. It won't be a function. So on the table, you can tell. On the map, you can tell. Just looking at your ordered pairs, you can tell. If they give you a graph, you do what's called the vertical line test. Like you have a function here, you just take a vertical line and skim it across, and as long as you're only hitting one point at a time, all the way across horizontally, then you'll have a function. If you have something like this, to where you have 2 points that you're hitting with your vertical line, it's not going to be a function. So your vertical line test on graphs will tell you. Then we have set notation, where we have f of x equals 3x plus 2, and they'll give you f of 2. So really all you do is take that 2, plug it in for x. So 3 times 2 plus 2, and we solve it. F of 2 will equal 8. Your homework's right here, page 41, 9 through 16, evens, or 9 through 16 all, sorry, and page 49, 16 through 36 even. And we'll also do workbook page 14, that's in 1-7.